In this video, we are going to discuss about the dual gate MOSFET, point contact diode, PIN diode, and avalanche photodiode. So first, let us see the dual gate MOSFET. In the dual gate MOSFET, as the name it is implies, it has the two gate terminals, and also the second gate which we are using in this gate is to control and to reduce the feedback capacitance. That feedback capacitance is produced to enhance the two input and output, and also this amplifiers are kept more stable. Here it is mostly made up of the high frequency RF amplifier applications, and the disadvantages of this normal MOSFET is high capacitance, so that it cannot be used at the higher frequencies. So here you can see the symbol of the dual gate MOSFET. First one is the N channel and the P channel. So in the dual gate D MOSFET, you have N channel as well as the P channel, and in the case of the dual gate E MOSFET, you are having the N channel and P channel. So depletion MOSFET and enhancement MOSFET is nothing but the terminals will be differ. In the case of the depletion channel, there will be a single channel, but in the case of the enhancement MOSFET, there will be a separate channel for each terminals. And here you can see the construction of the dual gate MOSFET. So as we have discussed, we have the three terminals: one is source, gate, and the drain, and the gate is made up of the gate oxide, and the major layer is completely covered with the gate metallization, and this MOSFET is a p-type silicon, that is NPN substrate. So here the double gate MOSFET is completely manufactured using the silicon on insulator method. This silicon channel is completely grown over a silicon oxide layer, that is SiO2. It is like two FET connected, that is connected in series, and also the highly doped layer will be act as a drain, and the first terminal is the source and the second will be the drain. Here the gate oxide between the gate and the channel is the dielectric layer which acts as an insulator, so that the metal used for the gate is also a conductor and the channel is also a conductor. So there are three layers that together form as a capacitor, which we are placing in the series, and each one is having individual capacitance, which will reduce the feedback capacitance at very high frequencies and allows the current to flow through it. Here you can see the working of the dual gate MOSFET. So in the above diagram, there are the two gates and the two FETs. They are the gate, bottom gate, and the top FET and bottom FET. In the top gate, voltage is applied and kept constant, and the bottom FET it is analyzed. When we are applying the voltage to 3 volt, the threshold at the top gate will be remains in the saturation region. And next one is the point contact diode. So the point contact diode is formed by touching a metallic wire with the N-type semiconductor to form a small area of contact. This forms a small point junction. So here some value of junction capacitance is formed, which is formed at the junction, and the storage level will be very low. So here the switching ability is much better than the conventional diode. In the case of the point contact diode, there is an N-type semiconductor substrate, or we call it as a phosphor bronze wire. This semiconductor will be used in the construction of the point contact diode and can be either a silicon or germanium, because it possesses the higher carrier mobility. The dimension of this semiconductor substrate is always about 1.25 mm, and the thickness is 0.5 mm thick. So one phase of the semiconductor is soldered to the metal base by the technique of radio frequency heating. So here you can see the basic structure of the point contact. So when you are applying the forward bias is applied to the point contact diode, the current produced in the device is passed through the Cadwitcher. So due to this, heat is produced, and this heat will undergo the deformation and produces a smaller gap. When the wire gets heated, the semiconductor and the contact with the wire will also get heated. Due to this, it gets melted and the atoms will be passing through the semiconductor material. So here the PN junction is formed, but the area junction is very small and is assigned to the pointed junction. So here you can see the construction features of the point contact diode. It is having a cat whisker between the anode terminal and the cathode terminal, and a supporting structure which is placed in both the anode terminal and the cathode terminal, and there is a glass envelope in between this one. The point contact is clearly mentioned, and the junction that is formed between this one is very small, and also it is made up of glass or ceramic envelope, This provides the mechanical strength to the device, and also the junction capacitance in this diode is very small, that is up to 0.1 to 1 picofarad. So this is because of the area of contact between the wire and the end substrate is very small. Due to this smaller area, density of charge carriers near the junction is very low. Thus the low charge storage imparts it is the ability to switch fastly. And pin diode is the diode with a wide undoped intrinsic semiconductor region between the p-type and the n-type semiconductor. The p-type and the n-type regions are typically heavily doped because they are of having the ohmic contact. So you can see the pin diode in the diagram. So it is having 3 layers, and the p and the n regions are present, but between them there is an intrinsic material which is having the low level of the doping. Here is very lightly doped region between the N and P junctions, and heavily doped regions are separated by the intrinsic region. When reverse bias is applied to it, it produces the constant capacitance. When forward bias, it brings us a variable resistor. And here the construction, when this PN junction is unbiased, no voltage is applied, and the diffusion of the electrons and the holes will produce a depletion layer which will penetrate with a little distance in the p-type and the n-type semiconductor, but it can be formed with a high level of resistance in the case of large distance. When you are applying the forward bias, the width will be decreases, and in the case of reverse bias, the width will be very thicker because the thickness of the depletion layer increases the current region, because which becomes the mobile carriers to flow rapidly. And next one is the avalanche photodiode. This is also designed by the Japanese engineer, and this diode will produce extra performance when compared with the other diodes. So that's why we call this as avalanche photodiode. And also it is used to change the signals from optical to electrical, and it has a high reverse process. And the construction is, it consists of 2 heavily doped and 2 lightly doped regions, that is P plus and N plus, whereas lightly doped are current I and P. And here the working principle is avalanche breakdown occurs mainly once the photodiode is subjected to maximum reverse voltage. This voltage enhances the electric field beyond the depletion layer, and the charge carriers which are present in the saturation velocity due to the Pn plus region are whenever the high electric field exists. When this velocity is highest, then the charge carriers will collide with the other atoms and produce new electron pairs. And here the characteristics of the avalanche photodiode. This is very sensitive high speed diode, and which is having the internal gain method that works with the reverse voltage. This will be operated for a long distance. Thank you.